Hi, friends. Welcome to another episode of Decluttered. In today's episode, I want to walk all of you through a very interesting question of limits, which was in a JEE paper a few years ago. So, the question is that we have to find the largest non negative value of A such that limit x tending to 1 minus ax plus sine of x minus 1 plus a by x plus sine of x minus 1 minus 1 to the power 1 minus x by 1 minus root x is equal to 1 by 4. I'll leave this on the screen for a couple of minutes. I urge all of you to pause this video here, attempt the question yourself, and then come back to the solution. One advice, avoid using L'Hopital's rule to the best extent as possible, because I firmly believe that it's a hack to solve problems in questions that require less time. But when you're preparing for such topics, I would honestly urge you to go thinking through the first principles. All right, coming to the solution now. Let's look at why this is a limits question. If I substitute 1 in the numerator, I will get sine 0 plus minus a, which is 0. And the numerator will be sine 0 plus 1 minus 1, which is 0. So it's a 0 by 0 raised to the power 0, which brings us to a limits question. Let's look at how we can simplify this scary looking expression, right? If I focus on the power, it is 1 minus x by 1 minus root x, which is nothing but 1 minus root x into 1 plus root x, applying a minus b into a plus b formula. And the power is nothing but 1 plus root x. Now, this is not of a zero form. Hence, I have simplified the power to the best possible extent. Now, let us focus on what is inside the bracket. What is inside the bracket is minus ax plus sine of x minus 1 plus a by x plus sine of x minus 1 minus 1. What if I divide both the numerator and denominator with x minus 1? I can write this as minus a into x minus 1 plus sine of x minus 1 the whole divided by x minus 1 by x minus 1 plus sine of x minus 1 the whole divided by x minus 1. And we all know limit x tending to 0 sine x by x is 1, which will bring us to the fact that limit x tending to 1 sine of x minus 1 by x minus 1 is 1. So I have simplified the inside portion of the bracket to minus a plus 1 by 1 plus 1, which is 1 minus a by 2. And the power as 1 plus root x. Now, I'm just going to go to the next page and get closer to this problem. We have simplified the question limit x tends to 1 minus a by 2, the whole power 1 plus root x is equal to 1 by 4. Right? Now, it's very easy for all of us to substitute x is equal to 1 in the power. It will become 1 minus a by 2. The whole square is equal to 1 by 4. Taking a root on both sides. And if x square is equal to some value n square, x is equal to plus or minus n. The property of square roots. 1 minus a by 2 is equal to plus minus 1 by 2. This will give rise to a is equal to 0 or 2. A lot of people end up saying that the largest non-negative value of a is 2. But hold on for a second. I disagree that a cannot be 2. A has to be 0. The largest non-negative value that a can take for this question to be correct is a is equal to 2. A is equal to 0 and not a is equal to 2. The explanation to this is here. Let's see what happens when a is 2. 1 minus a by 2, the whole power 1 plus root x, right? When a is 2, this is minus 1 by 2, the whole power 1 plus root x. Limit x tending to 1, limit x tending to 1. One thing we have to understand that it's a limit question and it is not an exact value. So 1 plus root x is tending to 2. That is, it can be 1.9999999 so on, or it can be 2.000000001. And for such powers, negative to the power 1.9999999 is not possible, or negative to the power 2.0000001 is again not possible. And the basic rule of limits is that a limit is defined only when the left hand limit is equal to the right hand limit. Now, when a is 0, it is 1 by 2, the whole power 1.9999999, or 1 by 2, the whole power 2.0000000, which both of them are actually 1 by 4. Hence, the answer to this question is a is equal to 0. All right. If you enjoyed this video, please do like, share, and subscribe and spread the word. Thank you.